Okay, so I know you're all just dying to find out what happened. So we're back to fill you in on the cliffhanger. So if you remember right, if you watched the last video, we were stuck here because we tried the zero products rule and it didn't work because we couldn't factor this. So we couldn't get it to where it's something times something equals 0. So we need some other method. So there's a method called the completing the square. So we're going to talk about that method for a moment. So completing the square means that we're going to basically mess around with this so that I can factor it. Okay? Only in a unique way. So first of all, we need to talk about what a square is. So a perfect square, the term completing the square refers to a perfect square polynomial. So a perfect square polynomial. Fortunately, you guys already know what that is because we talked about it when we were factoring. A perfect square polynomial means that I can write it as like x plus 2 squared, for example, or x plus 3 squared, or x plus, or even x minus 2.5 squared. And so what we're going to do is we want to change this thing. This is not a perfect square polynomial right now. We want to change it so it is a perfect square polynomial. And the way we do that is, first of all, we need to recognize what perfect square polynomials look like. For example, if you multiply this out, you get x squared plus 4x plus 4. If you multiply this out, you get x squared plus 6x plus 9. And if you multiply this out, you get x squared minus 5x plus 6.25. Okay, and then we make this observation that that's true of every perfect square polynomial. So if you have a polynomial that can be factored like this in a perfect square, the half of the middle term is always equal to this. Or half of the middle term squared is equal to the last term. So notice half of 4 is 2, 2 squared is 4. Half of 6 is 3, 3 squared is 9. And half of 5, half of negative 5 is negative 2.5. And negative 2.5 squared is 6.25. So that's the goal, is to get a polynomial that, whoops, let me grab my cord and plug it in. Okay, so let's see. So we want to create a polynomial that looks like that. So notice over here, we have x squared minus 5x plus 15. And I conveniently created over here what I really wanted. If we could make it look like this, then it'd be a perfect square, right? So instead of 15 there, we want 6.25. Do you see that? Okay. So what we're going to do is there's a couple different ways to do this, but one way to do it is just to get that 15 out of there. So this would be x squared minus 5x equal to negative 15, because I subtracted 15 from both sides, right? Because again, what I'm going to do is try to build a perfect square polynomial over here. Or is it right there? Yeah, okay. So what do I want this to be? I want it to be 6.25, right? So I'm going to put a plus 6.25 right there. But I can't just throw it in there without following the rules of math, which the rules of math say if you do it to the other side, then you're fine. So I'll throw a plus 6.25 right there. Okay? So then the next step is, of course, to simplify a little bit. This is going to be, what, 8.75, negative 8.75, right? 14, 29, yeah. And nothing to do here as far as simplifying, so I'll just rewrite this. But now here's the magic of this completing the square method. When I go over here, remember that this thing here can be factored into this. So if I go ahead and factor this, I get x minus 2.5 squared, and that's equal to negative 8.75. Okay, so far so good. Now we're not, I want to be clear on this, we're not using the zero products rule, right? Because we don't have something factored equal to 0. But what we are going to do is we're going to go back to our original method now, up here where we're just undoing whatever's been done to both sides, right? Because right now, notice we only have one x in this equation, don't we? The only x is right there. So to undo this, what I would do is take the square root of both sides, which would be x minus 2.5. And I take the square root of this side. And we run into trouble. Everyone see the trouble we have here? I'm trying to take the square root of a negative number. So what does that tell me? Well, I cannot take the square root of a negative number, which means that there is no solution for this. So I'd stop and say no solution. Sorry, I did the first one that gives you no solution, but we'll do some more that aren't no solution. But so hopefully you saw the method there. So let's run through a couple more of these using completing the square method. So let's say we have x squared plus 8x minus 2 equal to 0. So first of all, we notice that there's an x squared and an x. So we can't use our normal method. We go to factor it. X, looks like got to be 2 and 1, and we're looking for a difference of 8. Impossible, so that's not factorable. So we erase that. So then we're going to go to our completing the square method. And the completing the square method says that you just got to turn that as a perfect square. So let's think for a minute about what we want. So if this is a perfect square, that would mean that half of 8 squared would be there. So what we're really looking for is x squared plus 8x plus half of 8 is 4, 4 squared is 16. That's what we really want, is x squared plus 8x plus 16. Because we know that this would factor into x and x, 4 and 4, plus and plus, which would be x plus 4 squared. And that would be a perfect square. So let's use the same method we did before. We're going to, first of all, add 2 to both sides to get that, to clear out some space. And we get x squared plus 8x, does that look like a squared, is equal to 2. And then we're going to create the perfect square. We're trying to create this. So I'm going to add a 16 here and add a 16 there. Okay, so far so good. So we'll simplify. So I get x squared plus 8x plus 16 is equal to 18. And now I'm ready to factor this other side. And we just did it over here. So that factors into x plus 4 squared equal to 18. And now I'm going to solve the traditional way where I just undo whatever's been done. So in this case, I'm going to take the square root of both sides. So that would give me x plus 4 is equal to the square root of 18 or negative square root of 18. Yeah? That looks interesting. So really, I'm going to create 2 equations here, aren't I? X plus 4 is equal to the square root of 18, and x plus 4 is equal to negative square root of 18. And then I would subtract 4 from both sides, and I get x equals square root of 18 minus 4. Whoops, that should have been a... Yeah, that's right. And this would be x equals negative square root of 18 minus 4. And I wouldn't quite be done yet because square root of 18 can be written in simplest form. So that would be x is equal to 3 times the square root of 2 minus 4. And this would be x is equal to negative 3 times the square root of 2 minus 4. And that would be my 2 solutions. Isn't that fun? So that's completing the square method. So I think I'll do one more because this is kind of a complicated process. Let's go x squared. We'll go with the negative 6x is equal to, say, 14. And we could try to factor that by moving the 14 over, but I promise you it's not factorable. So we're going to use completing the square method. So I think about x squared minus 6x. What do I want this to be? Well, half of 6 is 3. 3 squared is 9, so I'd prefer a plus 9 there, because that will factor into x plus 3 squared. Right? So notice the 14 is already over on the other side, so I don't have to move it. So this is going to be x squared minus 6x plus 9 is equal to 14 plus 9. Because then I built the one I want. That'll factor into x plus 3 squared. And 14 plus 9, of course, is 23. And so now I'm ready to square root both sides. So that would be x plus 3 is equal to the square root of 23, or x plus 3 is equal to negative square root of 23. Subtract 3 from both sides, and we get x is equal to square root of 23 minus 3, or x is equal to negative square root of 23 minus 3. And that would be my two solutions. Isn't that amazing? Okay, so that's completing the square. I have one more method to teach you, and so that'll be the next video. So stay tuned. You won't want to miss this last one.